All right, so what today we're going to look at is how to graph this, how to look at the limit of a cosecant graph. And when you're looking at a cosecant graph, it just helps to just look at the graph, put it in your calculator, make sure your calculator is in radian mode. And once you're in radian mode, take a peek at what's going on. And so the limit that we're given on this question is we want to know what's happening as x gets close to, but doesn't touch 0 from the right. So we're going to move this direction towards 0. And as you move towards 0, we want to track the graph. And what I mean by track the graph is we want to follow that graph as we move closer to 0. So here's my graph. I'm moving closer to 0. And then what happens then as I get close to 0 from the right-hand side? And we'll notice that this is getting really, really close to, but not quite touching the y-axis. So what we would end up saying is that this limit right here from the right-hand side goes to positive infinity. The other thing that you could do is, if you remember what the cosecant of x looks like, it is 1 over sine x. And since it's 1 over sine x, anywhere that x is equal to 0, or anywhere that the sine is equal to 0, we have an asymptote. And if you have an asymptote, then you're going to have a limit that approaches infinity or negative infinity. Well, the sine of 0 is 0, and you cannot have that in the denominator of a fraction. And so as we get close to 0 on the x-axis, you cannot put that in for our limit because it makes an undefined expression. All right, this problem here wants to know where the asymptotes, vertical asymptotes, are for the given function. And vertical asymptotes occur everywhere that you get a 0 in the denominator, as long as there's nothing in the numerator that would cancel some factors out. And so let's just look at this guy real quick before we start worrying about things that cancel out or not. But if you'll notice, on this problem, we've got a 1 in the numerator. He's pretty much done. There's nothing else we can do with that. So we're going to have a 1 on the top. And then on the bottom, factor this. And when you factor this, you're going to factor to x minus 5 and x plus 5. And when you factor it this way, what you want to do is you want to take these bottom pieces and you want to set them equal to 0. And where those factors, where this equals 0, where this occurs is where we're going to have our vertical asymptotes. And notice that there's no x minus 5 or x plus 5 factor in the numerator. So everywhere that x is equal to 5 and everywhere that x is equal to negative 5, you're going to have a vertical asymptote. With this problem, what we're going to look at is how to find all the places where we're discontinuous for the secant of x. And for the secant of x, we're going to be discontinuous, and where those places are, they're going to be vertical asymptotes. So it'll be really easy to see from a graph what this looks like, and you can see that right now. But how can we show that kind of algebraically, or how do we know exactly where those things are, where all these asymptotes are? Well, remember, just like one of our previous problems, that the secant of x is equal to 1 over cosine x. So in order to find all our vertical asymptotes, we're just going to set cosine x equal to 0. And where does this happen? Well, think back to trig and think back to your unit circle. Up here at pi over 2, over here at 0 and 2 pi, over here at pi, and down here at 3 pi over 2. If we look at this and we put that unit circle in, remember that the x-coordinate is equal to the cosine. And our x-coordinate is 0 at 2 places, pi over 2 and 3 pi over 2. So where are we going to have these vertical asymptotes? We're going to have the vertical asymptotes at pi over 2. And then if you add pi radians, that'll give you 3 pi over 2. And if you add pi radians, that'll give you 5 pi over 2. And if you add pi radians, that will give you 7 pi over 2. So where does that happen? at pi over 2 plus k pi radians. And what is k? K is any integer. Any integer. So where are our vertical asymptotes for this guy? Right here, at all these pi over 2s plus k pi units.